So there's the answers from yesterday's assignment, the quadratic. How did everybody feel about that? Should have been pretty good. Again, you don't always have to use it. If you like completing the square, just another option for us as far as that goes. Today is, if you notice, that was 5-6. We're skipping 5-7 and 5-8. We're not going to go to those sections. So we're jumping up to 5-9, which is adding and subtracting, multiplying and dividing complex numbers. Not too bad today. It won't be real difficult. A couple of problems to do from homework. We're going to hit this section again tomorrow, 5-9. We're looking at a practice test and then a test on Tuesday of next week. So chapter 5, a whole chapter. Excuse me, that goes back to 5-2, you know, axis of symmetry. Some of those quizzes we've taken will come in handy for some review. So I'll give you a practice assessment also as usual, and you'll be ready, hopefully feeling pretty prepared for it. As we start to wind down, you know, before Christmas break, you know the exams are coming, right? So the exams are before we go on Christmas. Then we come back, we got a couple weeks left in the 9 weeks before, you know, the end of that 9 weeks, but the exams will be before Christmas for us. All right. We're gonna do operations. So when it says perform operations, what does that mean? Well, that means add, subtract, multiply, and divide, okay? So we'll be adding and subtracting. Let's start there with complex numbers. It's really quite simple, and I think you'll feel comfortable about it. We're gonna skip some of those warm-up problems today. And here's our first problem today, example number 1. Add and subtract. Well, when you add and subtract complex, you just add or subtract their like parts, okay? Also remember, we're always gonna have it in this form right here. Remember the real part first and the complex part second. So this first guy here is really very simple. You would want a bunch of these on your assessment. We have the real part of 4. We have plus -6, so we're gonna add those two real parts together. 4 minus 6 would give me -2. Now I'm gonna go for the complex part, plus 2i minus 7i minus 5i. And there you have added those numbers there. My friends, that's pretty straight up and simple today, isn't it? Okay, that's the start. Obviously, we're gonna make it a little more complicated, but that is really the base of it. Make sure you put what? The real part first, okay? So you do need to put that real part first. Add their like stuff, and you're done, okay? Now, of course, we can add a little twist here. It might be good for you to know that this negative has to be distributed. So I'm gonna rewrite this as 5 minus 2i, okay? It's gonna become plus 2, and it's gonna become plus 3i. So it is subtract that, so I'm distributing, of course, that -1 across the board there. Now it's just like the first problem, isn't it? What are my like parts? We have 5 and 2. I want to put the real part first. Gives us 7. We're going to have -2i and positive 3i, which will give me plus I. Again, real part first, imaginary part second. See if you can do that bottom one. We're going to distribute there and simplify. You have a subtraction, so that negative needs to be distributed. Sometimes if you don't see that, it does help if you put a 1 in front. So boom and boom. So adding like things. If we have a subtraction, most of the time we're going to be distributing a negative over that. So in this case, we'll distribute. We're going to get 2i minus 3 minus 5i after we distribute. Of course, we want the real part first, which is -3. We have 2i minus 5i would give us minus 3i. Adding, subtracting, how do we feel there? That's not too bad. I think all of us should do pretty well on that part of the assessment. Would you agree? Fantastic. The next thing, when we multiply, we're gonna get I squared, okay? And I squared is equal to -1, and that's gonna be the crux of multiplying. You're gonna take I times I, you're gonna get I squared somewhere along the line. I squared is -1. I mentioned that earlier when we got into these, that would come up for us. So we're gonna need that. And you can handle all your multiplying. Anytime I get I squared, I'm gonna convert it to -1 and simplify whatever's going on there. So multiplying, you've already been multiplying. You should feel pretty good about that. Let's go ahead and do this first one together. We will simplify it after that, so we do need to do that. So I'm gonna take this -2i times this 2, and I'm gonna get -4i. So -2 times 2, the I is coming along. Now I'm gonna have negative times negative, which will give me a positive. So I'm gonna get +8, but I have I times I, so I'm gonna end up with I squared. Now, what is I squared equal to? Of course, -1. So in fact, this is really -4i plus 8 times -1, isn't it? Everybody see where we're going with this? So really that simplifies to -4i minus 8, -8. There's still one thing wrong with this. We have to put the real part first, and it's not. So my final answer is going to be -8 minus 4i. Always putting that real part in front.
So you can change I squared into -1, but
-1.
if it's just I, you don't do that with it?
You won't.
Remain it as I.
That's right. So I squared changes to -1. If it's just I, it's gonna stay. I believe you have it correct. I got you. All right, take a look at this bottom one now. What do we need to do here? Well, we got a couple things going on. It's a binomial. As soon as you see binomials in your algebra class, you need to think FOIL, right? So FOIL those out. See if you can combine like things. If we get an I squared, we're gonna make that -1. And see if you can simplify that down and give you about a 20-second head start on me. All right, let's distribute that 3. 3 times 4 gives me 12. 3 times -I gives me -3i. That's gonna give me positive 24i. And here I'm gonna get -6. There's my I squared, isn't it? So distributing those guys right there, how's everybody feel? All right. This guy right here, what does he change to? That changes to +6, doesn't it? So now I have 12 and 6, which gives me 18, doesn't it? And now I've taken care of my numbers. I have them out front. 24 minus 3, or 3 plus 24 is going to give me positive 21i. There you have it. Multiply. Couple things. What I squared is -1. Always put the real part first. Knock a couple of these out. second there. So you're foiling this first one. Notice what this is, those of you interested. Okay? 2 plus 9i, 2 minus, those are complex conjugates, aren't they? We've had that. We were finding that in one of our assessments, we had to find a complex conjugate. When you have a complex conjugate, it's kind of cool. Let's see what happens here. 2 times 2, of course, would be 4. 2 times negative 9 would be negative 18i. That's going to be positive 18i. And that's going to be negative 81i squared. What's cool about these complex conjugates, what happens to those middle i's? 18, they're going to cancel. This becomes what? Positive 81, doesn't it? So now I have 4 and 81, and I end up with 85. Make note if you can. When I have complex conjugates, 2 plus 9i, 2 minus, I'm going to end up with a whole number. The middle terms will cancel. Complex conjugates, the middle terms cancel, I end up with a whole number. Pretty shows the other two out. That's the only complex conjugates up there. All right, this guy's pretty straight up, just multiplying there, we're gonna get negative 30i squared, aren't we? Of course, we got I squared, so that's negative 1, so negative times negative, this ends up being positive 30, doesn't it? Positive 30. Now, don't think we got a whole number there just because we had I times I. It's not, those aren't complex conjugates of everybody. Does everybody understand that? That's just two single variables, two single things being multiplied, not complex conjugates. Distribute down there on that next one. Make sure that you simplify it with the I squared. Make sure you put the real part first. So when we distribute here, we're going to get 6i, right? Minus 10i squared. Of course, this 10i squared becomes 6i plus 10, right? And now we got to put the real part first. So this is 10 plus 6i is my final answer. How we go to multiply? So we added, subtracted, and multiplied. Does everybody feel okay? Pretty straight up, isn't it? You have that earbud hooked to this, so you get you want to actually listening. Right? What? All right. Now, this eye thing can get big. We're gonna have some large eyes. Okay. So I to the first is always going to be I. We already know what I to the second is. This is negative 1, right? Well, we can also have I to the third, which is negative I. And then here's the cool part. I to the fourth ends up being just positive 1. Now, we can have I to any power. It's always going to be one of these. So I'm going to have you say, hey, what is I to the 9th? Well, it's going to be one of those. Okay? They rotate every 4. Okay? So I to the 9th. So I to the 1st is 1. I to the 5th, that would be 4 more. That's still I. So I to the ninth turns around and it is just I. Make sense? On the other hand, I to the fourth is 1. So what would be the next I to the 8th? Would also be 1, right? What would be the next one? I to the 12th. Then I to the, how about 16th would be 1. 13th would, I to the 13th would be what? It would just be I. I to the 13th would just be I. How about I to the 20th? What would that be? Well, that's a multiple of 4, so that's just gonna be 1, isn't it? Okay? Now, you understand that it's always gonna be, no matter what power we have, it's gonna be one of these right here. It's either gonna be I, -1, -I, or 1. Does everybody understand that? So, bottom line is you can guess, you got a 25% chance. Strike couple. All right, that's a big one. I to the 42nd. Now, there's a couple of possibilities here. You can look for multiples of 4, or I can get my calculator and put 42 and start subtracting 4 until I get to either 1, 2, 3, or 4. I want to get it to be 1, 2, 3, or 4. Does that make sense? Well, one option is to say, well, in my mind, I'm looking for sets of 4, right? Well, 4 times 10 is what? 40. So if I just take 40 of those i's away, I'm left with what? I squared. Does that register? What is I squared equal to? -1. Okay, try this one. How about I to the 19th? What would I to the 19th be? Well, for me, I'm thinking, what's the set of 4? 16, right? 4 times 4 is 16. That's the best closest number. So really, I can take 16 of those i's away, and I'm left with what? I to the 3rd. And I to the 3rd is equal to? -I. You're catching on a little bit. Making sense? All right, I to the 63rd. See how far you can get with that one? I to the 63rd. Then go ahead, 1/2 I to the 7th. So we're gonna be simplifying these, okay? We have I to some power, we're gonna simplify. 63rd. So in your mind, you gotta think, well, what is that? What is I to the 63rd? Okay, there's only 4 possibilities. It's either gonna be I to the 1st, I to the 2nd, I to the 3rd, or I to the 4th. It's either gonna be I, -1, -I, or positive. Those are the only possibilities, right? Those are the only possibilities for I to the 63rd. Well, I to the 63rd is really what? I to the, it is correct. It is really I to the 3rd. They are the same, so this answer here is -I. It simplifies to -I. I to the 63rd simplifies to -I. Now, when we start putting a number with it, we gotta just simplify I to the 7th. But what is I to the 7th? You should be getting a little better with that. I to the 7th is really equal to what? I to the 3rd. I to the 3rd is equal to? So this is 1/2 times -I. Okay, and we'll just write it as -1/2 I. -6 I, so the first goal on these is what? Gotta figure out what I to the 14th is. All right, so if I take 4 away, 12. 12 would be my closest thing to 14 of multiples of 4, right? You see where I'm getting at? Okay, so really I to the 14th is equal to what? I squared. So we end up with -6 times I squared. Of course, we know I squared is -1. So this whole kit and caboodle ends up being +6. Jonah, how you doing back there?
I think
I hope you are. I think you got it. I think you do. I to the, let's go with 5I to the 14. Anybody got it already? It is -5. Why? Well, I to the 14th is the same as I squared, isn't it? 14, okay, I'm looking for multiples of 4. 3 times 4 is 12, isn't it? So that leaves me with just 2 left over, doesn't it? And so that's gonna be 5, and then we're gonna end up with -5 there. Let's go with, 10I to the 100th power. So you gotta figure out what I to the 100th is. I to the 100th. Now, listen, folks, it's either, if it's an even number, if it's, the last number's even, it's either gotta be what? -1 or +1. Hello, do you get that? Okay? So I to the 100 is either gonna be, so now we're down to 50% yes. Okay, but I to the 100 is really what? Is it I squared or is it I to the 4th? You sure? It is correct, it is. Okay, so it's the same as I to the 4th. So we have 10 times I to the 4th. We know I to the 4th is 1, so this ends up being just 10. So if that's the case, what would be 10I to the 101? 101 would be the same equivalent as I to the 1st. And I to the 1st is just I, so this would be equal to 10I. How are we doing with the I's? Everybody okay? Spectacular. All right. We are going to work with rationalizing the denominator here shortly, but we're gonna get to that section tomorrow. 12 to 29, make sure you skip, this is a graphing one, we're not doing any of those, we're not doing graph. Not gonna graph those complex numbers, so. Page 386, 12 to 29er. Tomorrow we'll do division. And then we'll start looking at the assessment coming up for chapter 5. Thank you all for participating today.